rate of reaction depends on many factors. Concentration is one of the factors. Temperature, another factor. Catalyst, another factor. So it depends on many factors, and here we can see the dependence on concentration. In a chemical reaction, as the reaction proceeds, the rate of the reaction decreases gradually. What is the reason for the decrease in rate of reaction? Because of the decrease in concentration of reactants. When the concentration of reactant decreases, rate of reaction decreases. It is a clear evidence for the dependence of rate of reaction on concentration. At the beginning, initial time, the concentration of reactants are high. So, a number of collisions will take place. A number of collisions will take place, and as a result, what happens? More amount of products will fall. As the concentration decreases, the frequency of collision will decrease, therefore the rate also will decrease. So we can say with increase in concentration of the reactant, rate of reaction increases. And the rate of the reaction is increases with increase in the concentration of reactants. So we can say rate of reaction depends on the concentration of reactants. We can see in a reaction AA plus BB gives CC plus DD. The reactants are A and B. Here, small a, small b, small c, and small d are the stoichiometric coefficients. That means number of moles of these reactants and products. In order to represent the dependence of concentration on reaction rate, we can write rate is proportional to concentration of A raised to X into concentration of B raised to Y. Here, X is the power of the concentration term A and Y is the power of concentration term B, but it is not compulsory that X is equal to A, small letter A. A is the stoichiometric coefficient or number of moles of A present in the balanced chemical equation. So in this expression, rate is proportional to concentration of A raised to X and concentration of B raised to Y. And here X and Y may or may not be equal to A and B. That is the difference. Then from where will you get the values of X and Y? Only through an experiment. It is possible to determine the value of X and Y only through an experiment. We cannot predict the dependence of the concentration of a particular reactant on reaction rate. How will it influence the reaction rate? That can be determined only through an experiment. So, the representation of rate of a reaction in the form rate is equal to K into concentration of A raised to X into concentration of B raised to Y is known as rate law. Rate law. Here X and Y may or may not be equal to A and B, which are the stoichiometric coefficients. And it is known as this expression or this equation is known as rate law. So what is rate law? Rate law is the expression in which a reaction rate is given in terms of molar concentrations of reactants, with each term raised to some power which may or may not be same as the stoichiometric coefficient of the reacting species in a balanced chemical equation. I think it is clear to you. The rate law, concentrations of reactants are raised to certain power, and that power may or may not be equal to the stoichiometric coefficients in the balanced chemical equation. And this Wright law is also known as Wright equation or Wright expression. I told you x and y are experimental quantities, and from the values of x and y we can define another term, that is order of a reaction. Order of a reaction. Here you can see some examples for Wright law. First one is CHCl3 plus Cl2 gives CCl4 plus HCl. Here the stoichiometric coefficient of CHCl3 is 1 and Cl2 is 1. But what is Wright law? Wright is equal to K. K is Wright constant. K is a constant, that is known as Wright constant. Wright is equal to K into concentration of CHCl3 raised to 1 into concentration of Cl2 raised to 1 by 2. So here the power of concentration time of CHCl3 is 1 and its stoichiometric coefficient in the equation, that also 1. But the power of the concentration time of chlorine is half, but its stoichiometric coefficient is 1. So stoichiometric coefficient different, but at the same time different from the power, but at the same time the stoichiometric coefficient and the power of concentration time of CHCl3 is the same. Of the second case, it is hydrolysis of an ester, ethyl acetate. CH3COO C2H5 plus H2O gives CH3COH, acetic acid, plus C2H5OH, ethanol. Here, what are the stoichiometric coefficient? You can see it is 1 here, and in the case of H2 also 1. But what is the Wright law? Wright is equal to K, Wright constant K into concentration of CH3COO C2H5 raised to 1 into concentration of H2O raised to 0. So stoichiometric coefficient and power of concentration time of H2 are different, 1 and 0. But the stoichiometric coefficient of C3CO8 C2H5 and its concentration term are the same one. So these are some of the examples of Wright law or Wright equation or Wright expression. What is meant by order of a reaction? Wright law can be represented as R is equal to K into concentration of A raised to X into concentration of B raised to Y. And the order of a reaction is X plus Y. What is order of reaction? That is X plus Y. X and Y are powers. So what is order of a reaction? Sum of the powers to which the concentration terms are raised in the Wright law. So what is order of reaction? It is the sum of the powers to which concentration terms are raised in the Wright law. That is order of reaction. Sum of powers of the concentration of the reactants in the Wright law expression is called the order of that chemical reaction. Here we can see some examples. Calculate the overall order of reaction which has the Wright expression. Wright is equal to K into concentration of A raised to half into concentration of B raised to 3 by 2. What is order of reaction? X plus Y. That means half plus 3 by 2. That is equal to 4 by 2 equal to 2. So order of reaction is 2. If the order of a reaction is 2, we can call it as a second order reaction. You see the case B. Wright is equal to K into concentration of A raised to 3 by 2 into B raised to minus 1. So what is order of the reaction? X plus Y. 3 by 2 plus minus 1. 3 by 2 plus minus 1. That is equal to 3 minus 2 divided by 2. That is 1 by 2. Or 3 by 2 is 1 and half, minus 1, half. So it is a half order reaction. So if the order is half, we can call it as half order reaction. If the order is 1, we can call it as first order reaction. If the order is 2, we can call it as second order reaction. If the order is 0, we can call it as zero order reaction. And if the order is 3, we can call it as third order reaction. And beyond 3, it is not possible because simultaneous collision between 4 molecules, very difficult to happen. So order can be whole numbers like 0, 1, 2, 3, or it can be fractions like a half, 3 by 2, 1 and half, or it can be 0. Order can be 0. So I think it is enough for today, and in the next class we can see examples or order of reactions and unit of rate constant.